In this video, we're going to talk about how to balance a simple chemical equation. Here's a reaction that is common in combustion engines. Octane reacting with oxygen gas to produce carbon dioxide and water. To balance the equation, start by making a T-chart. Organizing your reactants and products. Place each kind of element in the center. Now, make sure that you count up each kind of element that you have on each side. On our reactant side, we're starting with 8 carbons in the octane, 18 hydrogens in the octane, and 2 oxygen atoms in that oxygen molecule. On the product side, we have 1 carbon currently, 2 hydrogens in that water molecule, and 2 oxygens from carbon dioxide, and 1 more oxygen from water, for a total of 3 on the right product side. Now, to balance this chemical equation, we will start with the elements that are only in one compound. The rules of balancing chemical equations state that we can't change the identity of the chemicals in the equation, but we can change the coefficients in front of them, implying that more moles of these molecules are around. Let's start with carbon. Since I have 8 carbons on the reactant side, I'm going to put an 8 in front of my carbon dioxide molecule. This implies now that I'm going to have 8 carbons and 8 times 2 oxygens for a total of 16 from that carbon dioxide molecule. However, I need to remember that I have 1 more oxygen on that water molecule for a total of 17 on the product side. Next, we will balance the hydrogen. I currently have 18 hydrogens on the reactant side, so I need to figure out a way to get 18 hydrogens on the product side. I have 2 hydrogens in each water molecule, so I can put a 9 as a coefficient in front of that water molecule. This changes my number of hydrogens to 18, but it also changes the available oxygens. Instead of 1 from the waters, now I will have 9. 9 plus 16 from the carbon dioxide will change the 17 oxygens into 25. Now that we've balanced our elements that occur in only one compound on each side of the equation, let's handle oxygen. Oxygen is left for last because it's a little bit more complicated. Alright, I need to have 25 oxygens on both sides of the equation. This is kind of weird. Oxygen molecules only come in pairs. So if I had 25 pairs of oxygen molecules, I would actually have 50 atoms. That's twice as many as I really need. But if I took half of each of these 25 oxygen molecules, I would have 25 oxygen atoms. So the key is to have 25 halves of each oxygen atom. This may seem a little weird, but don't worry, in our next step, we're going to get rid of fractions. To get rid of a fraction in a balanced chemical equation, you do exactly what you would do in algebra. We're going to multiply every single chemical in this equation by the denominator on the fraction, by 2. So we'll end up with 2 ethane molecules, 25 oxygen molecules, 16 carbon dioxides, and 18 water molecules. This may look a little messy, so you're going to want to clean up your final answer. The fraction step is not always necessary. If you get to the point in a balanced chemical equation where all of the atoms are balanced, you're set. Go ahead and report that answer. Also, it is conventional to only use the simplest whole number ratios for coefficients. So make sure that your answers, the coefficients in front of your chemicals, cannot be divided by the same number. In this case, our odd number 25 keeps us safe so that we don't need to divide anything else to be more simple. Make sure that you practice plenty of these problems because the ratios that we get from the balanced chemical equations are essential in all future stoichiometric calculations.